Okay, Trevin, we're just getting ready to start quadratic formula, which is halfway through the notes, but I kind of went through this flow chart here, and I said that when we are solving equations, and particularly quadratic equations, so x to the second power, right? Factoring, we can do factoring, some of these factoring methods with things that are like x to the third power, that type of stuff, okay? But factoring, these are the methods that we have for factoring, okay? Now, the problem is you can't always factor. Sometimes they come out really disgusting. You can always complete the square with quadratic equations, and you can always do the quadratic formula for quadratic equations, okay? So that's kind of our list of options. Are we good to go? Should we go back to quadratic formula? He's up here at example like 6. Quadratic formula. Do you guys have it memorized?
Nope.
Okay. I would, if I were you, try to memorize him. You will need to know him. Okay? All over 2a. Like most of the time you get done with this section and you're like, I haven't memorized whether I wanted to or not, because you just do them all the time, right? Okay? There's that little riddle. Do you want me to give you the riddle? No? They haven't heard my riddle yet, though. Do you want me to sing this song?
No. Give it to them in geometry.
Okay, plug your ears. Here we go. Plug your ears. Get out of here. Quit throwing things at me. Okay, a negative boy. Here's the riddle. Here's the riddle, Addison and Casey. Okay, a negative boy couldn't decide whether or not to go to a radical party. But being square, he decided not to go and missed out on 4 awesome chicks. The party got over at 2 a.m. Dumb. So dumb. So dumb. Quit throwing things. Get out of here. I'm going to keep those all. Don't. I'm done. Okay? So, whatever it takes for you to memorize him, this is how you factor him. Now, real quick, some of you guys can do this, but you don't even know what it means. What are we solving for when we plug into this equation?
X.
We're solving for x. What does that mean? Like a quadratic equation is a parabola, right? Okay? Okay, put this off to the side. So a quadratic equation is a parabola, right? And we have 3 different scenarios that could happen when we're factoring this parabola, or when we're breaking them down, right? We could have, and what we have most of the time, is 2 answers, right? Where he crosses at 2 places. We are trying to find the zeros. We are trying to find the solutions, right? We are trying to find the x-intercepts, okay? We could, though, maybe have a parabola that looks like this, where it only has one solution. In which case, the solution is also called the what? The vertex of the parabola. It's the little low point, okay? Now, it could end up going the other direction. It can be the high point, whatever, right? All this works for all these other ones. Or
No touch.
maybe he doesn't touch at all, in which case my solutions are?
Zero solution. Nothing. Zero with a line through it. Danny does not exist.
All real?
Imaginary. Yeah? We'll end up with eyes, right? We'll end up with the square root of a negative. Okay, well, I'll show you what that looks like. All right, so quadratic formula. We're trying to break this guy down.
You know what I learned?
What?
Google taught me that a basketball shot is not a parabola.
Is what?
An upside down parabola.
Yes, exactly. It's projectile motion. You will learn that. Maybe you'll learn that.
We won't learn that in physics.
Yeah. You'll learn that in this class, in Trig, right? Oh, projectile motion is quadratics. Boop. Okay.
You honestly teach us physics in this class.
You do. You do learn a lot of physics. We do vectors in this class, which is what you do in physics. Oh, you will love the way I teach vectors. It's so easy. Vectors are easy. I love it. Okay. All right, quadratic formula. Here we go. Let's get back on track. We need to put this guy into the quadratic formula, but before we do that, we have to make him a quadratic. Let's fix him, right? X squared minus 6x equals 3, and I'm going to bump the 3 to the other side because we're not completing the square. So I'm going to put the 3 over here. X squared minus 6x minus 3 equals 0, okay? We have to have him equal to 0 in order to do the quadratic formula. All right, now, we have an A, a B, and a C. If you don't, some of you don't need to write this out. That's fine, okay? What is A, though? 1. B is negative 6. C is negative 3. All right, negative B plus minus square root B squared minus 4AC all over 2A.
Why do you write
Why
like
do you
that? Why not
sing
just
it?
plug it in already?
Because I'm writing the formula out for those people who need it, okay? So, negative b will be negative 6, which would be positive 6, plus minus the square root of b squared is negative 6 squared, which is positive 36.
48. What's the square
Minus
root of
4 times 1 times negative 3.
6 plus or minus
All
the
over
square
2
root of 48.
times 1. Okay? Here's where we're at now. All right, negative 4 times 1 times negative 3 is positive 12. And then I put those together, and that is
48.
48. So right now I am at 6 plus minus the square root of 48 all over 2. Okay, 48 does in fact break down, and you're going to not break them down big enough. Focus on 48. Think big. 16 and 3.
Whatever.
The square root of 16 is 4, and the square root of 3 is the square root of 3. So now I have 6 plus and minus 4 square roots of 3 all over 2.
3 to 2.
Okay? 6 and 4 and 2 can all reduce by
2.
2. So we have 3 plus minus 2 square roots of 3. There's what we have. All right, now, question. We just found the zeros, right? Where he crosses. How many places does he cross?
2.
2, right? Because even though there's only one answer there, there's actually 2. Because one of them is 3 plus 2 square roots of 3 and 3 minus 2 square roots of 3. So I can figure those out as decimals if I want to, and he's going to look like this.
0.15.
No, just
Boop,
stop.
those two. Okay? Does that make sense? Casey, Addison, that is 2 answers, right? And they're just ugly decimals where he crosses, right? Okay? All right. Ugh. They don't last very long on that thing, and now we're solving rational equations, I guess, or something. I don't know. All right, example 7. I thought they were going to elaborate more on that, but that's okay. Okay. All right, this guy. We have 3 pieces, and we are solving for x, and we have x's in the bottom, and that's a problem.
Bring the x's to the top.
Okay, really quick. I'm going to make a note of this. What can x not be equal to? 0, right? If x is 0 here, that's a problem. If x is 0 here, that's a problem because we'll end up with 0 on the bottom. So I'm going to make a little note of that because in the end, if we get 0 as an answer, then we won't have an answer, right? Okay? All right, so when we're doing this is 3 over 1. What's our strategy here? Get a common denominator. All right, so I've got 3 pieces. This guy, plus this guy. I set them up just like normal.
2x.
I have x, 2x, and 1, and my common denominator is, Lauren said it, 2x, and 2x, and 2x. Okay? Then I've got a 12, a 6, and a 3.
You got,
You just wait. Just give it a second.
and, yeah.
Okay? That's what I have. But now, just like we did in the last section, I have to multiply by what he needs, and multiply by what he needs, and multiply by what he needs, all right? Okay? So, going from this x to this 2x, he needs a
Go.
2, right? Going from this 2x to this 2x, what does he need? Nothing. So I'm going to put a 1 in there if you want to put something. Okay? You don't have to put anything, but you can put a 1 there. What does this guy need?
2x.
He needs the 2 and the x, right? Okay? All right. This is my favorite part.
Why?
Are you ready? This is my favorite part. When there is an equal sign, and only when there is an equal sign, as soon as they have all the same bottoms,
Don't care.
the bottoms are gone now. Because there's an equal sign. Right? They are all gone. If you are just adding 2 of them together, you have to keep the bottom. But if there's an equal sign, you can knock the bottom out. Okay? So,
It equals 3.
2 times 12 is 24. Shush. Equals 6 plus 6x. And now we solve. And that's easy. Subtract the 6. 18 equals 6x. And x equals how much? 3. Can x equal 3?
Yeah.
Yes, so just can't be 0, right?
Chill guy.
Okay, so there we go. Good?
Chill guy.
All right. Was that a lot? They've all had this in Algebra 2. And I taught them, so I know that they should know that. But I don't know if you guys... I didn't teach it to you guys, so maybe she didn't teach it the same way. What?
What does this even graph like?
What? Well, we don't have a y involved, so there's no... It won't even graph. But,
Would it just be like a line?
no, if x is on the bottom, he's like one of these guys.
What? Ew, a nasty.
A boomerang thing. He's a rational equation. Rational functions graph either like this
Oh, would he
Or
a volcano.
or like a volcano if he's squared.
But would he just be a point though? Like if you were to put x plus x equals
Right. He would just be a point. Yeah. Yeah. Okay. All right. This one. We do in fact have an equal sign on this guy. Same process though. But we've got to make the bottoms all the same. Before I do the bottoms, I'm going to do one thing real quick.
Simplify.
Nope, I'm not going to break them down yet. I'm going to do one more thing. What am I going to do first?
Break down that simple trinomial.
Nope, I'm not going to do that.
The top?
Nope, I'm not going to do that.
I don't know.
You got a
Find out what
factor.
it can't.
Nope, I'm not going to do
I
that.
don't know.
Oh, no, you're wrong.
X can't.
Bring the sign over. I don't know.
Plus, minus.
Why?
Otherwise, it will screw you up. I swear to you. Do that to begin with because you will forget to distribute the negative with the 3. I promise you. Do it. All right.
Like a back. Black lady.
Okay. This guy right here is a simple trinomial. Let's break him down. Multiply to get negative 8, add to get negative 2.
X plus 4x.
X
X minus 4.
minus 4 plus 2. Okay, real quick. Judging by those 3 things on the bottom, what can X not be?
0.
No.
4 and negative 2.
X cannot be positive 4 and X cannot be negative 2. Does anybody not understand why that is? It's the opposite sign. You're like setting it equal to 0, right? Okay, so X can't be those 2 guys. All right, now I'm going to set up my 3 pieces. So I've got this guy plus this guy equals this guy.
Why you do
I don't know. I just always do it that way because then I don't screw it up. Okay, so what's my... I know from this guy I need to have an X minus 4, right?
that? And an X minus 4. And X plus 2.
I know I need an X minus 4. I know I need an X minus 4. Okay? I know from this guy I need an X plus 2. And an X plus 2. And an X plus 2.
Which is the way you do things.
You know what? I write it all
He
out.
doesn't care.
I write it all out because there's people in here that I have not taught this before ever. So I want to make sure that they see all the steps. Otherwise, if I fly right through, they're going to be lost. Okay? And Dylan's going to be lost no matter what. So I got to really go slow. Okay? All right. Now, going from this guy to this guy, I know that I need an X minus 4. I already have one. I know I need an X plus 2. I already have one.
Top student right there.
Yeah, right.
Sure, it hurt you to say
It did. It hurt me so bad.
All
right. Ready? 2x is here. Negative 3 is here. X squared plus 14 is here. Now we got to multiply by what they need. Shh. Here we go. We got to multiply by what they need. All right. What's the first guy need?
X plus 2.
X plus 2. I'm going to put that here. Then the second guy needs
X minus 4.
X minus 4. What's the third guy need?
Nothing.
Nothing. So I'm going to put like 1 there if we want to put anything. Okay? Favorite part. Favorite part. Cancel the bottoms. Only because there is a equal sign. All right. Now we're going to distribute.
2x plus 4.
Wait. Got to put a square in there. Right? 2x squared plus 4x. Okay? Now, see, if you didn't put the negative with the 3, you forget to distribute the negative through. So minus 3x plus 12 equals
X squared plus 14.
x squared plus 14. Okay, now we got to decide what we're going to do from here.
Move the 12 over.
No.
No.
Simplify the
Put them
Okay.
together.
Here's the deal. We've got x squareds, we've got x's, and we've got numbers.
Subtract that.
The x squareds, if I put those x squareds together, are they going to go away?
No.
No, so I am going to have a trinomial in the end. So I need to make sure that I get them all onto the same side. So I'm going to bump these guys over here. Yeah.
You have to subtract a Rooney and then you get negative
All right,
2.
so x squared, I'm going to subtract this x squared here, and I'm going to subtract the 14 here. And I'm going to put stuff together.
Positive 2 times
So,
negative
just
1.
shush, be quiet. 2x squared minus x squared is 1x squared, all right? 4x minus 3x is plus x. And what is 12 minus 14? Equals
0.
0.
And that should be x minus 1 and x minus. No, that's wrong.
X plus 2 and x minus
Okay, are we to this point? Do you see what we did? That was a lot. He is a simple trinomial. What can you multiply to get negative 2? But when you add them, give you
positive 2 and
1.
negative 1.
x plus
So
2
the answers are
and x minus 1. I bet you get it wrong.
X
The
and
only
positive
answer
1.
is X plus 1. Yeah, because you can't have X
Okay,
minus 1.
so if I set this guy equal to 0, if I set x plus 2 equal to 0, x equals negative 2, right? And if I set x minus 1 equal to 0, x equals positive 1, right? But we said in the beginning that x cannot be negative 2, so my only answer is
X plus 1.
x equals 1.
Wait, why
Do we see how that works?
Why can't
because in my original I had x plus 2's. So if I would try to plug in negative 2 back in here, this would end up giving me 0 in the denominator, and I cannot have that, right? Okay? So x equals 1 is my only answer there. Got it? Woo!
Are we done?
Okay, let's do a little bit of absolute value and then we'll stop. We got a lot. Like, this is a long section. Let's try to get these two done. Okay, so then we have a few more homework problems to work on. Okay? All right, solving absolute values. Solving absolute values. Okay?
So that's just
I have to make sure that I...
Do plus and minus.
No, yeah, just wait a second. I have to make sure that I first...
Distribute.
No, you can't distribute. You cannot distribute over an absolute value. Okay? We have to isolate the absolute value. That means I have to get this by itself before I can do anything else. It's kind of like, I think on your homework assignment you had like 3 square roots of junk minus 10 equals whatever, and a bunch of you asked me like, what do I do first? You got to get rid of the 10, divide by 3, get this by itself, then you can do the thing, right? Do you remember that homework problem? Yeah? Okay. Okay, so you have to isolate the absolute value. So I'm going to divide by 2. That's going to get him gone. Divide by 2. So, starting out, I have the absolute value of 3 minus 2t equals 3. Now, here's the deal. Here's the deal. Every single absolute value, you're going to set it up this way. You are going to split the paper in half, and you're going to do 2 cases. 1, 2. Every time you have an absolute value, you're going to do this. Every time. Okay? The first case, you're just going to get rid of the absolute value bars, and you're just going to go 3 minus 2t equals 3. Okay? But when you have absolute value bars, it turns a negative into a positive. So I don't know if this 3 in here was negative or positive. So in the second case, I have to treat him as though he was negative 3, right? Same thing with this negative 2t. I'm going to flip the sign of that, right? Because when I put absolute value bars around this, it ends up being the same as that. So I have to look at the 2 different cases. Does that make sense? Okay? So when you have an absolute value, first you're going to do it without changing anything. You're just going to drop the bars. The second thing that you're going to do is drag a negative through the absolute value piece. Yeah?
0 and 3.
yeah, I got 0.
Now we're going to solve.
0 and 3.
So on this left side, if I subtract the 3, negative 2t equals 0. And if I divide by negative 2, can you take 0 and divide by negative 2?
Why not?
Yes, just not 0 on the bottom, right? So t equals 0. Perfect. Okay? This guy, I'm going to add this 3 over. So I have 2t equals 6, and then divide by 2, and t is 3. There you go. Okay? Good? Absolute values. Everybody like that, right?
No.
Okay, here we go. B. We have to subtract the 8 over first. So here's the deal. You're going to get this one wrong.
Nuh-uh.
What'd you get?
Oh, you can't
Okay, I'll do it real quick.
I did it faster. Oh, Zach. Zach says this guy has no answer at all.
Why that?
It's negative 6.
Is no matter what W is, right? If I plug him in and I do all this stuff and I take the absolute value, is there any way that this is going to end up being a negative thing?
No.
So will it ever end up being negative 6?
No.
W has no solutions because it's equal to a negative, and you can never have absolute value of something equal to a negative. Now, here's my question. Let's say we have this. Let's say we have like this. Could that end up being negative 6? Yes. What about this? If I change this to a positive 10, will that end up being negative 6? No, right? Okay. So we're clear that anytime you have them set equal to a negative, you will end up with no solutions. And you can just put that, and then you don't have to do your 2 cases, and then everybody smiles, right? Okay. Ready? Next. Let's talk this guy. A, you're going to get a question like this, all right? Now, for just a minute, I want you just to watch real quick, okay? Okay, just watch. Don't write anything down. Are you ready? Just watch. Don't write anything down. Okay? Just watch. Don't write anything down. Don't write this down. Because I have 2 absolute value bars, there are 4 cases. But I'm going to show you what happens.
2 of them is.
Ready? So if I take and I drop the absolute value bars, case number 1 is that 2x minus 5 equals x plus 1, right?
Yeah,
Okay.
baby.
The second case is if 2x minus 5, I leave him equals negative x plus 1, right? And I drag the negative through the second piece. The third case
Oh my.
would be as though, just wait, would be as though I take the 2x minus 5, make him negative, and have him be x plus 1, right? Or I drag a negative through both of them, which is 2x minus 5 and negative x plus 1. But here's the deal, okay? Case 1, 2, 3, 4. I have 4 cases. You got it? You see where I get those 4 cases generated from?
Yeah.
Yeah? This guy is
They're the
the same as
the bottom.
this one. Because the 2 negatives cancel each other out, right? I can divide both sides by negative and get back to that one. So this is the same as above.
So there's only 3
Same.
cases.
Okay, now we're down to 3 cases, right? But what happens if I take this guy and I divide this negative 1 over to the other side?
It's the same thing as that
It
one.
becomes that case,
So there's only
right?
2 still.
So this guy is the same as that one, okay? So when you are doing it, listen to this. When you are doing it where you have the absolute values on both sides, what you're going to do is you're going to drop the absolute value bars for the first case and treat everything positive. The second one,
pick
you
your
make
favorite.
one side negative and it doesn't matter which side. Does that make sense? Okay, you could do this side if you wanted to, or do that side. Doesn't matter, right? Because the 2 cases end up being the same as the other 2 cases. Got it? All right, let's solve. So I'm gonna subtract this x over, and I'm gonna add the 5 at the same time. Can I do that? So I get x equals 6 in that case. Yeah, does that work? Okay, this guy, do x minus 5 equals, distribute the negative through, negative x minus 1. Yeah. Okay, now
Add the x.
I'm going to add the x over, and I'm going to add the 5 over. Woo! So 3x equals 4, and divide by 3. Okay, let's just call it 4/3. Was that too fast? Was that okay? Okay. Good. Very good.
Move on to homework.
Okay, let's do B and then we'll stop. Because we're done with opposite value sections. Okay? All right, so now we know that we can just do 2 cases, right? Okay? So the first one I'm going to do 6 minus x equals x minus 6, yeah? Okay? Then the second one, what would you like to do?
Negative x plus 6.
Negative x, what? Okay, 6 minus x equals negative x plus 6. You're going to distribute the negative through this guy? Sure?
That one's 0.
All right, so let's solve. This guy, if I add the x over, and I add this 6 over, I get 12 is equal to, stop. 12 is equal to 2x. And x is equal to 6 on that side, right? Shh, you boys are very irritating.
Quiet.
Okay, this one,
C squared.
if I add the x over,
Cancel. Cancel.
okay, well, hold on. Let's see what happens. Those cancel, and I end up with 6 equals 6. Wait a minute.
Identity.
Oh, real.
It's an identity,
Oh, real.
which means that x can be any number, right? Not just 6. That's what I got over here. I can plug in any number. Let's see if it works. Let's plug in the number 1. 6 minus 1 is 5, right? Absolute value 5 is 5. 1 minus 6 is negative 5. Absolute value negative 5 is 5. I can plug in any number I want to. Okay? Good? So, all real numbers. Yeah? So, really, this is gone because all real numbers trumps that it's 6, right? Okay? I can plug in anything I want to. All right, there you go. Solving radical equations is where we stopped, so you should be able to get through, I don't know, let me see. Solving radical, rational. No?
9.
No. That's rational. These are radical.
80
So,
sucks.
up through 102.
What? We don't have
No.
We can
I know. But, like, that's where the section stops. So, up through 96.
80 is
So, in the last 2, you
I
cannot.
thought 80 was
Okay?
gonna be a good
Up through
roll.
96.
80
Hold on,
was
I'm going to
not
stop
a good
recording.
roll.
it's not that
Any questions for the good of the cause?
No, it's fine.
Or for
I'd rather
Trevin?
do that.
Bye, Trevin.
She's like